gonna continue. This is the review for the final. This is question 9. These couple questions deal with radicals, rational exponents like this one, and I think up to the question 13 it deals with the complex imaginary numbers. So to solve for this one, because for these tests you guys can use a calculator if you guys have the calculator. So again, this is the radical, radicand, root. You can solve this one, at least the number part. So what does that mean? This is the fifth root of this. So you're trying to find a number where you multiply 5 times, that would give you this one. I think it's 20. So you multiply 25 times. For 5, should give you that. So that's a number. I know I did this ahead of time. I think I'm like, wow, I know it. Who knows? Who's gonna know fifth roots of huge numbers like that? I just know that this is a number that you multiply 5 times, that it will give you that. And you can tell by the last number, like 2 times 2 is 4, times 2 8, times 2 16, times 2 32, which is this, and then you add the zeros. So the fifth root of this number would give you, so this is 5 times, so negative 20. Negative 20 for this. So that breaks out of the radical. Now this part, the x, so remember this exponent can be divided by the roots by 5. So negative 20 x to the 4th. 20 divided by 5 would be to the 4th, and that's how you can find the radical, the root of x to the 20, the fifth root of x to the 20, by dividing that number by the root. And that's the answer. Okay, number 10. Simplify the expression and leave no negative exponents. So this is a negative 1/4. This is an exponent. It kind of doesn't look like an exponent, but it is. So before we can do anything, I'm going to bring this whole thing to the bottom. And you can bring the negative if you want, or you can leave it on the top. So the whole thing, I'm going to bring it to the bottom. So 1/4 is positive. This is what I mean. The negative, you can put it here, or you can put it up here. So let's say I want to keep it up here, I just put the negative 1, right? Because there's nothing, so you just put a 1. If you wanted to put it with this, you can put a negative here, and then the 1 without that. Just the negative would be here. Okay. So here, what happens is this is where you would distribute that exponent into the other exponent. Remember, 81 has a 1 as an exponent. This one has a 4, the x. So you would have negative 1 and 81 to the 1/4, right? 1 times 1/4 is just 1/4. And x would be 4 over 4. Like that. So negative 1. This part, 81 to the 1/4, can be expressed as a radical, and that would be 4 root of 81 times this 4 over 4 would just be x. So I'm going to simplify this. We know 4 over 4 is just the x by itself. So from here, negative 1. So the 4 root of 81. So a number that you multiply 4 times, that will give you 81. And that would be 3 times 3 times 3 times 3. 3 times 3, 9. 9 times 3, 27. 27 times 3 gives you 81. So the 3 is 4 root of 81. That breaks out of the radical, and then you have the x. And that would be the answer. So simplify each term and combine like terms if possible. So this is the ones that you have to see. Okay, this is the square root of 27, 108. You need to be familiar with your perfect square roots, right? Remember, perfect square root would be square root of 4, square root of 9, that gives you 2, that gives you 3, square root of 16, that gives you 4, square root of 25, that gives you 5, square root of 36, that gives you 6, and so on. Those are some. So we know 27 is not one of them. So this is where you guys have to start breaking things up. I know for sure 81 would, the 108 wouldn't be 1. I know square root of 81 is 9. Square root of 100 is 10. And then after that, 11 times 11, that would be 121. That would be 11. So we can say that 108 is none of this. So again, this you would have to break. And well, you guys know this. I skipped 7. 49 would be 7, and 64 would be 8. So these are the perfect square roots. So one of these can divide this, and I'm talking about this ones. I know 22 divide by 9, so I'm gonna rewrite this as 9 times 3 minus 2. 108 I think can be divided by 36. 36 times 3, and then minus, and then square root of 3, just you can't do nothing about it. That's it. So from here, 6 square root of 9 would be 3, so times 3, and then the 3 stays inside. So this one breaks out as a 3. Minus 2 square root of 36 would be 6, and then that one stays inside, and then this. So 6 times 3 is 18, square root of 3. 2 times 6 is 12, square root of 3, minus 7, square root of 3. So we have simplified the radical. Now we need to see if we can add or subtract in this case. So in order to add or subtract, they need to have the same radicand, which they do. They need to have the same index. Everyone needs the square root, so yeah. And there's no x's outside, just numbers. So also, if there were x's and y's here, they would also have to match. Any radical would have to match. Any index in the radical would have to match. Any letter outside of the radical would have to match for each one in order for us to combine the coefficients. In this case, there's no letter, so we just have to worry about the radical only. So now we can combine this. So 18 minus 12, so minus 12 and 7, that would be 19, negative 19, so I'm going to skip that one. Minus 19 square root of 3. So 18 minus 19 would be negative square root of 3, like that. That would be the answer for that. Okay, this one. So for x in rationalized denominator. So solve for x. So in order for us to solve for x, we need to get rid of that radical. So we're going to divide by square root of 5. So this goes away. So we have x is equal to negative 3 square root of 6 over square root of 5. So we cannot have radicals in the denominator, so we need to rationalize it. Rationalize. This is where we're going to rationalize. So we're going to multiply by this radical on the bottom, and on the top you're going to use, when it's a square root, you can multiply by the same thing. When it's a square root, automatically multiply by the same thing. That's going to rationalize the denominator. So this 5 times 5 would be 25, square root of 25. I'm going to put them together. This would be negative 3. 6 times 5 is 30. I'm going to put them together because they have the same index, so you're allowed to multiply them and put them inside. So this from here what happens? This simplifies this one. The top stays the same. There's nothing we can do. This becomes a 5. So like that. That would be the answer for 12. So we solve for x, because x is not on this side. I should have carried the x, but x was equal to this, and that. So x is equal to this. I should have wrote it like that. It's the same. Okay, let me see, 13. And then 14, 15, 16, you guys should know how to do those. We've seen them before, but I'm going to do 13. We've seen it like recently, the following questions here. And I do have some of I have the answers in case you need to see these ones. So for these ones, what is it asking? Writing in the form of a plus bi. Okay, so in order for us to write it in this form, well, we can't have this one. We need to rationalize. Denominator again. So for this one, you do the conjugate. To rationalize, you use the conjugate. The bottom one. The conjugate would be you keep the same terms. So the 3 in the I, and you change that to a positive. That's the conjugate. 3 plus I, and then you multiply like that. So that the conjugate will get rid of the I. Okay, so the top part and the bottom part. So we're gonna have to FOIL like that twice. So this is what we have so far. So we're gonna have to FOIL twice. So we're gonna have to FOIL like that and then like that. So 4 times 3 is 12. 4 times I is just 4i. And then the middle 3i. And then I times I would be plus I squared. Over 3 times 3 is 9. Plus, and then 3i plus 3i. Minus 3i. Minus I squared. So I FOIL this part, these ones. And that's what I got. So for the top parts, it gives me 12. 4i plus 3i gives me 7i. And then I squared, you guys should remember that I squared is equal to negative 1. Don't forget this, guys. So this I squared becomes a negative 1. Over 9. 3i minus 3i, it just becomes 0. That's why we do the conjugate to eliminate the imaginary part. And that's why we want these two things in the middle to cancel. And this one, you know, it's going to become negative, right? I squared is negative 1, and we already had a negative. So 12 plus 7i minus 1. Oh, I should have simplified here. I'll do it next step. 9, so this would be plus, so 10. So this becomes a plus. I forgot 2 negatives. So I forgot to simplify the part. 12 minus 1 would be 11 plus 7i over 10. That would be the answer. The book likes to separate the numbers for them because they want it in this form. A plus bi. So they're separated. So it would be 11, 10 plus 7, 10 over I. That's the answer.